This is Space Nuts. Andrew Dunkley here with Professor Fred Watson, and a big hello to our patrons, the people who've been supporting us with a couple of dollars a month to keep the vessel afloat, the HMS Endeavour, as we try. That was Captain Cook's ship, by the way, as we try to pass on valuable information in a language that you can understand adequately. But to our patrons, thank you. Whatever way you support us financially, it's certainly appreciated. And if you want to go to patreon.com/spacenuts, you can see how it's all done, or go to our website, spacenutspodcast.com, and click on the subscribe button to find out how you can assist us. We're aiming to become 100% supported by our patrons. And of course we need to get the numbers up, so if you would like to become a patron, it's not expensive, and you can choose your poison basically, but as I've said many times, it's not mandatory, so please don't think we are going to make you do this. That's not how it works. It's a volunteer thing, but to those many who have already done so, it's greatly appreciated. So Fred, let's move on to our next question. This comes from Paddy and Alyssa.
G'day, Fred and Andrew. Paddy here again. My daughter is here with me, and she asks about rainbows through glass, because each time we get home from work, or I get home from work, Alyssa always points out the rainbow on the driveway, and I said to her, it's a light spectrum, I think, dividing the light into different colours, so the rainbow, and then she says, no, it's not. There's a leprechaun. We have to find the leprechaun at the end of the rainbow, and there's gold. And I'm like, oh, okay, rightio. So what makes a rainbow, and can you explain it to my daughter, Alyssa? Thank you, and may the force be with you. Thanks, guys. Bye.
Thank you, Paddy, and hello, Alyssa, and I'm all on your side in regard to the leprechaun and the pot of gold. I do believe it, and I haven't found it yet, because you can't get to a rainbow, because the more you try to get to it, the further away it gets. It's one of those strange, it's one of those things that they just do to us to make us frustrated, I think. But we had a recent question, Fred, about rainbows from I think it was a bus driver who noticed at certain times in the day it was coming through the edge of his window and creating this incredible effect on the dashboard. And from time to time you do see them. I've seen them with the garden. The sprinkler system in the garden. Sometimes it's a lovely effect, but I guess we can educate Alyssa a bit in terms of what's going on. Well, you can. I'll just sit here and look pretty.
Well, thank God one of us can. Seeing them in the garden is lovely, and this is something I don't tell many people, and it's the kind of thing that you probably shouldn't tell many people, but when I'm in the shower, between about October and March, I can see rainbows in the shower.
Oh, wow.
Just from the shower spray, because there's the window in our shower faces east, and it's just at certain times, those certain times of the year, the sun is high enough in the sky, or in the right position in the sky, to shine on the the droplets of water coming from the shower, and they make a rainbow. You've got to look hard for it, though, but it is there.
Yeah.
And that's telling you exactly how rainbows are formed. It's billions of raindrops, and the sunlight passing through them actually is split up into the colours of the rainbow, the spectrum, exactly as Paddy says, and reflected back to us. It's really interesting. What's happening in each raindrop, Andrew, is that the light is going into the raindrop. It's being refracted, that means bent, by the front surface of the raindrop. Then it reflects off the back surface of the raindrop, comes out of more or less the same side that it went in, but at a slightly different angle. And the end result of that is that the light is bent actually through an angle of 138 degrees, which means that if you're standing with the sun behind you, what you're seeing is light that's actually coming from at an angle of 42 degrees to the basically to the direction of the sun, where the sun would be I'm getting, I'm not putting this well at all. It's what we call the antisolar point. Is the point directly opposite the sun, and it's 42 degrees to the antisolar point. So what you get is this arc of light centred on the antisolar point, the point directly opposite the sun, and it's caused by all these gazillions of raindrops bending light through this 138 degree angle and splitting them into their colours. A very, very complex account, but the bottom line is exactly as you've said. In a sense, a rainbow is an optical illusion, because as you move, the rainbow moves with you. If you went towards one end of the rainbow to dig up the pot of gold, and we used to believe there was a pot of gold at the end of it as well.
I didn't know there was digging involved. I would,
Yeah, you've got to dig.
Manual labour should not be required.
No, in Yorkshire you had to dig for everything. It didn't matter what it was. You had to do something. Aye, by gum. You couldn't just go there and pick it up, So the rainbow, you head towards the end of it where you think the pot of gold is, and the rainbow just goes with you because it's this kind of optical illusion. It's always this 42-degree arc in the sky. They're delightful things. Honestly, I think rainbows are completely magical, and I look out for them whenever I can see them, especially in the shower.
I'm going to ask a question of you in addition to what Paddy and Alyssa have brought up.
Good.
Are rainbows unique to Earth, or could they exist on other planets? And here's another sort of side question to that question.
Yeah.
Let's say you're on a planet where it's raining and it's a blue giant star rather than the colour of our star. Would the rainbow be different?
Yeah. And look, you've hit a point there. The kids' book that I've been working on, it's going through the editing at the moment, and I had a little feature on alien rainbows, exactly what you're asking about.
Oh,
and
how about that?
Yeah, except that the publisher says we haven't got room for this.
Oh no,
should cut it out. So it's going, I'm afraid. I might try and sneak it and mention it somewhere else because it is a lovely topic. I might actually, in fact, I've worked out how to do it, and I'll change it and make it shorter rather than make it as long a feature as it was. But the answer is yes, Andrew. And one place where, even in the solar system, there might be rainbows is Titan.
Of course.
Saturn's moon Titan, because Titan has a water cycle similar to the Earth's, except it's not water, it's hydrocarbons, it's liquid natural gas. But there are probably, we know because we see clouds, we believe that you would see clouds of droplets of liquid methane, ethane, which is what it is, in the atmosphere, and that would give you rainbows. They wouldn't be as colourful as here on Earth because, as you know, Titan is covered with this smoggy atmosphere, which is like an orange fog. So a lot of blue light would be taken out. So your rainbow would look predominantly orange, basically. And it's a different angle as well. If I remember rightly, it's 48 degrees, the radius of a methane rainbow, rather than the 42 degrees, the radius of a water rainbow. So, yeah, they'll happen. One of my colleagues, just as a final footnote to this, one of my colleagues from the University of New South Wales, and the group that he leads, Jeremy Bailey's his name, is a very senior and extremely expert astrobiologist. He and his colleagues are looking for the signature of rainbows on other planets beyond the solar system, and you do it by looking for the polarization of the light rather than looking for the arc of light. If you see, because rainbows are highly polarized. If you look at a rainbow here on Earth through polarizing sunglasses, turn your head around, you'll find an angle where it disappears altogether because the light is polarized.
Is that right?
Yeah.
I'm going to try that. Yeah. Speaking of books, Fred.
Yes.
My clever brother, has come up with this. I don't know if you can see it.
Oh, that's the one. That's the cover.
Yeah, that's the cover. I've put it in the right place. That's the cover of my new book.
Yeah.
Yeah. He's done a great job. And that'll be out next month. I've just decided to fast track it and get it out there because, why wait?
Yeah.
And I don't have to go through all the rigmarole of editing and convincing publishers I shouldn't put certain photos in the book. I'll just do it myself. But thanks again to Paddy and Alyssa for the rainbows question. Let's move on to a question now from Ralph.
Hi, Drew and Dr. Fred Watson. So this is what it feels like to be near a star. We wake up in the morning, it's daylight, and we take it for granted. We walk outside and see sunlight beaming everywhere, reflecting everywhere, and we feel its warmth on our skin. But what this really is energy rocketing at us from our nearby star. We're exposed to it directly for half of our rotation and are shielded from it during the other half. So this is what it feels like to exist near a star. We look out in the night sky and see billions of other stars, but we're told the universe is mostly space and emptiness. Our only experience is what it feels like to be in the neighborhood of a star. So what's it like to be out in the middle of nowhere, not anywhere near any stars? Is it simply cold and dark and nothingness, or are there faint wisps of energy from nearby galaxies, or dark energy affecting that space, or gravity? Is there anything? We take our existence here for granted so much, I'm just wondering what the opposite would be like, not in the neighborhood of a star. Keep it up, Chief Nuts. Love the podcast, as always. This is Ralph in Northern California. Thank you.
No worries, Ralph. Thank you very much. There'd be no rainbows. No, I don't imagine, unless you created one yourself.
Yeah,
I think it'd be pretty cold and dark, and it'd be pretty boring too, I think.
It's interesting, and I do have the answer. And actually, you upstaged me a bit there, because what I was going to do was put this up in front of the camera.
Exploring stars and invisible planets.
Exploding stars, yeah. It's the US edition of what's called Cosmic Chronicles here in Australia. And the reason I grabbed it before we started, because I knew this question was coming up, is because that is exactly how the book starts. It starts with a typical place in space, and I'm going to, since I've done it already, I'm going to read the beginning of the book. In fact, I might read the first two paragraphs, if that's all right.
This is, fine. This is going to be interesting because Fred has to read his own writing.
Yes, indeed.
Sorry.
Okay, suppose you could come with me to a place that is typical of the universe, a location that experiences the average conditions found throughout the whole of space. Where would we be? On the surface of an alien planet, perhaps, luxuriating among exotic plants and strange, colourful creatures. Or close to the brilliant churning atmosphere of a hot star with tortuous magnetic fields funneling lethal bursts of plasma towards us. Oh, what writing. Falling into a black hole, perhaps, or just nowhere. And it's the last of these that is closest to the truth. A typical place in the universe is empty, cold and dark, and nothing in our experience can quantify just how empty, cold and dark it is. If you're lucky, you might find one atom of hydrogen in the volume of space normally taken up by 15 adults per cubic metre. The temperature you'd experience is 2.7 degrees above absolute zero, or minus 270 degrees Celsius. That is cold. And to your unaided eyes, the darkness is complete. But don't worry, I'm not going to leave you here. And you've got to read the rest of the book to find out what everything else is like. So it is typical universe, place in the universe. There's essentially nothing. There's the odd hydrogen atom. There's probably dark matter, though, which we can't experience, in any other way than through its gravitational attraction when it gets to large numbers. But we know dark matter outweighs normal matter by 5 to 1, so that means you might find 5 atoms of dark matter, whatever it is, in that 1 cubic metre of space, the average space between the galaxies. Extraordinary.
There you go, Ralph. So it is. Ralph's opened a can of worms, but it's okay. There's nothing in it.
There's nothing. So that's right.
Great question, though. Really good question, and I kind of figured that's where we'd go with that one.
Yes.
A typical piece of the universe is basically nothing.
It's just nothing.
Yeah. Oh, that's kind of like my scorecard after a round of golf. Nothing to write home about. Thank you, Ralph. Appreciate it. And we will take a little break and come back with our last two questions on this episode 250 of the Space Nuts podcast.
Space Nuts.
You've been listening to the Space Nuts podcast.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.